Hey guys, my name's Leo, and I'm your Math SAT tutor. So today I'm going to really go over some August predictions for the SAT. Obviously, we all know that the SAT is coming up, and there's going to be more in the next coming months. So I'm just going to talk about what problems I think are going to be common on the SAT, and then I'm going to give you some practice problems to work with. All right, thank you. Okay, so what's really important to start with is really what the SAT is testing. So this is the official College Board SAT suite of assessments, and this will really tell us what we really need to study, and we'll make sure that we don't have to study any topics outside of the SAT. So clearly here we have algebra, advanced math, problem solving and data analysis, and geometry and trigonometry. And quickly looking at this, we see that our main focus is going to be algebra and advanced math. Now, if you really want an 800, which I mean, nowadays everybody wants an 800. You need it for IVs, you need it for good schools. I would say really you have to focus on making sure everything's right. You can't just focus on getting the majority of questions right. So of course you have to focus a lot on algebra and advanced math. But just because problem solving and data analysis, as well as geometry and trigonometry, have less problems, doesn't mean you should focus on it more. I think second, what's really important is now that Desmos is allowed, I think that advanced math and algebra are going to be a lot easier to solve. I mean, you can really just plug in values. If there's an intersection, you just plug in values. But for geometry and trigonometry, you're really not going to be able to use Desmos as much. So as a result, I really think that those problems you're going to have to hone on. And so I'm going to give you some problems for geometry and trig, as well as some big problems, some wordy stuff, because I think you'll get tricked up on that realistically if you are shooting for your higher scores. Okay, guys, so let's start with a quick question on trigonometry, because I think trig is pretty simple on the SAT, but I think it's very easy to get messed up, and I really think it's easy to take a lot of time on the questions. I remember I took the SAT in March, and one of the questions that really tricked me up was just a simple trig question, because it's a lot of drawing, and if you really mess it up, if you look at it wrong or something, it can really trick you up. So I'm just going to give you a quick question. It's not too hard in my opinion, but I think it's probably one of the harder questions they'd give for trig. I don't really see too many super hard ones. So looking at it here, in the figure, point C is the center of the circle. Line segment AC has length 6, and angle BCE has measured 2 pi over 3 radians. What is the length of arc BDE? So we see a circle here, right? And I'm gonna draw this here. And we know that AC is 6, right? So we have point C here. So obviously we know that this would be the radius, right? Because center to any point in the circle, that's a radius, and this is 6. So our radius equals to 6, right? So, and we need to find the length of arc. And right away when I see length of arc, I think circumference. So let's find our circumference. If any of us have been paying attention in school, circumference is 2 pi r, right? So let's plug in r, we get 6. So obviously circumference is 12 pi, right? So now that we have our circumference, let's figure out the length of the arc. So our arc is somewhere like here, from this point to this point, right? And we know it's 2 pi over 3 radians, right? And now what's important is to know how radians work. So if you know how radians work, you know that pi is 180 degrees, right? So in this case, we have 2 pi over 3. So if we do the math, it would be 120 degrees. You can do pi over 3 would then be 60 degrees times 2 is 120. So this is the same as 120 degrees. I really recommend for the SAT, learn your radians. I think it's going to be super important for you to know them, just in case there's a question that mentions that instead of degrees. Now, next, we know that this arc has an angle of 120. And let's think about this logically, right? So if we break the circle up into 3, right? Because the whole circle is 360 degrees. All these arcs are 120 degrees here, right? And all of these arcs are the same length, right? So let's call this x, 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 right? And that means 3x equals 12 pi, right? And we just have to find 1x, right? And divide by both sides by 3, we get x equals 4 pi, right? So we really broke down this problem, and I mean, looking at it, it's not too bad. I mean, we're just finding a third of a circle. So that's how you would approach that. Okay, let's move on to maybe one more trig question, and then we'll look at some advanced problems. Okay, so let's move on to another trig and geometry question. Here it is. I'm going to give you another, as long as you need, pause the video, and then you can come back to solve it, and then I'll show you how to solve it. All right? Okay, we're back, and for this, I think to start, we always want to draw it, right? So let's draw this triangle. It's a little sloppy. A, B, C, right? And then make sure you can see C. right? And then we have a line here. I know it's not very up to scale. I don't think it's as important. So this is 6, and this is 30, right? We just have to find x. Now, I would say for this question, all we really have to do is find like missing variables, right? So we know that this is 30 degrees. So then what would this be? The whole angle is 90 degrees, so obviously this would be 60. If this is 60, we know that this is 90 from our original graph. So that means this has to be 30, right? And now it's we can quickly see we have a 30, 60, 90 triangle right here. And we know in 30, 60, 90 triangles, the side opposite to the shortest side is half of the hypotenuse, right? And this is because law of sines, because we know that the x over sine 90, why did it do that? Sine 90, keep it like that, equals to 6 over sine 30. It's all degrees, sorry. Right? And this is important because sine of 90 is 1, sine of 30 is 1/2. So it ends up being x is just 12. I mean, 6 times 2 is 12. And so that's our answer, x equals 12. And it's that simple. Okay, so I'm going to now move on to some more data analysis. I'm going to give you 2 more questions, and that'll wrap up the video. Okay, guys, so let's move on to some data analytics. Here's the problem. Kudzu is a vine that was introduced to the United States from Japan in 1876 as an ornamental plant. Starting in the year 1935, kudzu was planted throughout the southeast to combat soil erosion. By 1946, kudzu covered approximately 3 million acres of land in the southeast. 60 years later, about 7 million acres were covered by kudzu. Which of the following functions best models the amount of kudzu in millions of acres 2 years after 1946? Okay, pause the video, try your best. When you have an answer, unpause. Or if you want to see the answer right away, I guess you can keep watching. Okay, so for this question, we're really going to look at the parameters, right? We know that each year it increases, right? It doesn't just start at 1946, it keeps increasing. So answers C and D kind of look weird. I mean, it doesn't really make sense for it to be 3 plus. I mean, also you can look at it. We're gaining 4 million acres in 11 years, right? So none of the answers really look like correct. So I mean, we can cross this out, but we can also think about this logically, right? Every year it increases and it's exponential, right? And we're starting at 3, and we know if we plug in 0, we're gonna get k of 0 is equal to 3, right? So we can look at all these work for 0, but we're probably gonna have 3 times some x to the power of t, right? That's what all exponential functions look like. This is the form we're gonna look at, and we know that it increases. I mean, in 1935 we had 3 million, or sorry, in 1946 we had 3 million, but 60 years later we had 7 million, right? So it increases. So A just does, I mean, A is the only one that looks right, but let's look at the other answer choices. B is 3 times 0.014 to the power of t, and that means it will decrease. C is 3 plus 1.014 times t, right? And that doesn't really make sense because we're increasing based on our previous growth, right? Because it doesn't make sense for the 3 million acres of land to stop growing all of a sudden, right? They're still going to keep growing. And same with D. Okay, and now if you really want a proof on this, you can use Desmos, and I'm going to put you a little demonstration up here. I'm going to record just me plugging in the function, and you'll see that it is 7 billion in 60 years. Okay, so let's move on to one more question. I'll see you then. Okay guys, so let's finish off with one more hard probability data analysis question. So, a box of fruit candy contains 50 candy pieces in 5 different colors: red, orange, yellow, green, and purple. Willie opened the box and found that 22% of the candy pieces are purple. If the box Willie opened is representative of that particular brand of candy, which of the following best estimates the total number of non-purple candy pieces in 36 boxes of the same candy? Okay, so I'm going to give you some time, pause the video, take as long as you need, and then come back. Okay, so to solve this question, it's pretty simple. We're going to think about what percentage of the candy is not purple. Okay, so we know that 100% of the candy is candy, right? Minus the 22% that is purple, right? And we'd come out to 78%. So that means 78% of the candy is not purple. Okay, so now we can find our total amount of candy. And we know there are 50 candies in one box, so 50. Right, times how many boxes? 36, right? And now this is going to be our x, right? And the x is total candies, right? Right? And now we know that 78% of these are going to be non-purple. So our final answer is just x times 0.78. And I'll pull up me doing it on Desmos here. And we'll see that the answer is around 1,404. And it says what is the best estimate. Obviously, there's going to be variance, right? Some boxes are not going to be exactly 22%. Some boxes are going to be over. Some boxes are going to be under. So looking at the answers, obviously 1,404 is closest to C. So our answer is C. Okay, guys, so thank you so much for watching. Please subscribe, leave a like. If you're taking the test on any of these days, I wish you the best of luck. I really hope you do well on the reading, on the math. I recommend you watch some more videos. I recommend you solve some more problems. Obviously, these aren't all the problems that are going to be on the test. There's going to be some more algebra. But I think you have that, and just be really confident, all right? Trust yourself, and you got this, all right? Thanks for watching. Have a great day.